dashboard. All right.
You got the video.
I remembered. There's hope for me
That
yet.
means I don't have to remember.
You have to remember to tell me to turn it off.
Will she? Most likely.
Okay, everybody in?
No.
All right. Let's see who is. I got Chloe, Mark, Haley, Jasmine, Jahan, Josiah, Kimberly, Christina, yay. Natalie, Rachel, Samantha, Simone went offline, and so did Coop. See some sad faces. Are we having a bad day just because we're here?
It's a
or
long day.
It's a Monday, but it's on Tuesday.
Mm-hmm.
All right.
Even though we watched the movie.
Yeah.
Fine.
Did
Me
you
and
watch
kids.
War Horse?
Yeah.
Yes.
Was it good?
Yeah, we got to
So far.
1 hour and 9 minutes.
Okay.
Overall.
All right.
So we get to finish it on Thursday. Through Zoom.
Okie doke. So let's start out with celebrations. Here's our leaderboard. Chris, yay, is in the lead now. Followed by Peter and then Rebecca. The 5 of you just kind of keep flip-flopping around. Stars for the week. Let's see. Christopher and Rebecca. Rebecca, you can come up here and get candy. And for the class contest, what happens with that is you have to have earned 10,000 points before you can start donating. And you have to go in and donate them to the class.
Oh,
Okay?
that's weird.
Does that mean everybody
That's
gets
really
them?
weird.
Yeah, no, when you get to 10,000, then you can donate points to the contest.
That's really weird.
Okay? So that's how that works. So congratulations to these people. Got lots of good things going on. The rest of you, let's see if we can get on board and get some, just change up this leaderboard a little bit. Oh, there's DeLeon. Okay. So Stephanie tracked how far she traveled each hour of her trip. Her results are recorded in the graph below. What do you notice about the graph? What do you notice?
It's proportional
How do you know it's proportional?
The line goes straight.
because it's a straight line and it goes to the origin.
Okay, what else do you notice? I heard you, don't worry, I heard you. What else do you notice?
Time is on the bottom.
Time is down here and distance is over there. It's usually the other way around, isn't it? Okay. Anything else you notice?
Did someone
I
already say
noticed
it's
that.
proportional?
They traveled 480 miles in 10 hours.
Okay, so you looked at this and saw this right here. So they went 480 miles in 10 hours. So what would their unit rate be? 480 miles in 10 hours. What's the unit rate?
48 miles.
48 miles per hour. Okay. How did you get that?
Divided by 10.
Whoops. Yep. So if we saw at this point, you saw it as, let's try that again. 10 comma 480. And remember we do y over x. So that's going to give us 48 miles per hour. What would her equation be? If I was to write an equation for that line, what would it be? Y equals 48x. Okay? John used the equation y equals 50x to calculate his average distance traveled, where y is the distance in miles and x is the time in hours. Who traveled faster?
John?
How do you know?
Because he went 2 miles further in an hour.
Okay, so his speed is 50 miles per hour. So John went 2 miles further.
Yes.
Okay, about a third of you got that wrong. So what do you think you did wrong? Any ideas? Hmm?
Finding the graph, like where.
The graph messed you up? Okay, so what helped today that you understood the graph? Anything? Remembering to find that point where it crosses. You could have also gotten it here at 240 and 5. It crosses right there as well. Okay. Anybody else got anything they want to add? Okay. We are doing lesson 18. When I checked this morning, only one person, Kimberly, had done the slides. Yay, Kimberly. I don't know if some of you had done it since, which could be. Okay. That was at 7:15 this morning when I
She
checked.
checked them either early in the morning or last night.
Right. All right, our learning goal is let's find ways to work with subtraction in expressions. What's an expression?
It's like an equation but without a equal sign.
Okay, so what does it have to have? It's like an equation without an equal sign.
Doesn't it have to have a greater than
No.
A constant
Has to have a constant, at least one constant. Has to have what?
available.
A variable if it's an algebraic expression. And what are you going to do with a variable and a constant? Do they just sit there? That has to have an operation, right? Adding, subtracting, multiplying, or dividing. Okay? All right, so now we're going to get to our learning goals, or our targets here. I can rewrite subtraction as adding the opposite. Oh, we've been doing that for a long time, haven't we? Yep. And then rearrange terms in an expression. What property lets us change the order of numbers? Commutative property. So we're going to use that. And then I'm going to show you a way to organize your work to do the distributive property that I think will be really helpful to you. Okay? All right, so let's start with that distributive property idea. All right. So if we think of this as a rectangle, how would we find the area of this piece of the rectangle right here? We would do 3 times 2/3 x and get an area, right?
Yeah.
If we wanted to do the whole thing, would we do 3 times adding these two together?
Yes.
Yes.
Isn't that that?
Yeah.
2 times adding that together?
Yes.
Okay, so I have taken this, which shows I need to distribute to simplify it, and put it in this model. Down here is the number that everything gets multiplied by, because it's also right here. And then up here, you have a box for each of the terms. Notice it's got addition. It doesn't make sense to be subtraction, it needs to be addition. Because this line plus this line is going to equal everything there. Okay? So how would I find the area of that? What did you say? 2/3 x times 3. Okay, so what is 3 times 2/3 x? 2x. So in this box, you can just put 2x. All right, how would we find the area of this box? 3 times 5y, which is going to give me,
15y.
yep. And that's 3 times 5y. All right, questions on how we can use this box to help us with distributive?
I need a little bit more time.
Okay, you're fine. Now, the way we had talked about distributive before was to think of multiplying 3 times 2/3 x, which is going to give us that 2x. See a plus sign, put a plus sign, and then 3 times 5y, which would be 15y. If you're comfortable with using that, it's fine. If you get confused, go to modeling it with the box. Okay, the box will help you a lot.
Question.
Yeah,
So, I know we're not supposed to actually solve it, but where it says 2x plus 15y,
okay.
does it matter that that variable says x and the other one says y?
Yes, it does matter. Can we,
It does?
yes. Do we know the value of this term?
No.
No, this is an x term. And until they tell us what x is, we don't know what its value is. All we know is it's 2 times some number. Do we know the value of this y?
No.
Therefore, we don't know the value of this y term because it's 15 times some number. Now, x and y will not be the same number.
So would the answer be whatever?
This is your answer. Because we do not have an equal sign, it's not an equation, we can't solve this. We can simplify it, but we can't solve it. Until they tell us what x and y equals, there's nothing else we can do than that. Okay?
Yeah, that makes sense.
Okay. That makes
Excellent,
sense.
excellent question. Okay, anything else I can answer that you don't quite understand? Okay? All right, so in this one, we are being asked, are these expressions, why are these expressions not equivalent? Okay, well, what does equivalent mean?
The same.
The same value. They have the same value. So there's 2 ways that we can, do you have a question? There's 2 ways that we can prove whether something is equivalent or not. The first way is to plug in the same number for whatever variable and see if they equal each other. Okay? So what number would you like to plug in for x? Pick a number.
6.
6? Okay. So we're going to go here. What's 6 plus 2? 8 minus, let's see, you said 3 times 6 is 18. So 8 minus 18 is? 8 minus 18 is?
Negative 12.
Negative 10.
Negative 10 minus 10 is? Negative 20, right?
Yes.
Okay, so we're going to take the same 6. 6 plus 3 times 6 is going to be, 3 times 6 is 18, plus 6 is 24, minus 2 is
22.
22, minus 10 is
12.
12. Do they equal each other? No.
No.
Okay, an easier number to have used would have been 0, but that's okay. First core we used 500, so. Okay, so have we proven that they're not the same that way?
Yeah.
Okay, if they were equivalent, then we could plug in any number for the value of x in both of them, and they should equal each other. Now, another way we can prove it is we can simplify it. Our first step to simplifying is to turn it into an addition problem so we can move things around. Because you can't move things around in a subtraction problem, can you? Is 4 minus 1 the same thing as 1 minus 4?
No.
No, okay? But if I have an addition problem, can I say 3 plus -4 is the same thing as -4 plus 3? Yes. So we're going to change this into an addition problem. So this stays x plus 2 plus -3x plus -10. Nothing new there, is there? We've done that before. Now we're going to use the commutative property to move like terms next to each other. We have an x term. Is there another x term up here? Right here, right? All right, I'm going to move this over to there. So I have x plus -3x plus 2 plus -10. I just used the commutative property. Now I'm going to use the associative property to group them. This is not distributive, this is associative. Associative groups them. Now, why did I group these two together? Why do you think I grouped these two together? They're both x terms, right? If I have 1 positive x and 3 negative x's, can I add them together? What do I get? 1 positive and 3 negatives.
You would get 2 negatives.
So I'm going to have -2x. Okay, why did I group these together?
Because they're not variable terms.
They're
or
not
they don't
variable
involve
terms.
the variable.
They're constants. Can I add those two together? What is 2 plus -10?
-8.
Okay, so this whole thing right here simplifies to -2x plus -8. Okay, we put the variable term first and then the constant. Okay, questions you have on that?
I need a few more seconds.
You're fine. All right, what I want you to do is work on the second one and make that as simple as possible. Let's see what you get for that one. Go. Simplify the second one. Josiah, -2x is not the answer. Go ahead and simplify the second one. First step is get rid of subtraction. Then move things around so the variable terms are next to each other. Oh, they look like they are next to each other. Then group them using the associative property and then simplify. Okay. Good. So I saw people do this. X plus 3x plus -2 plus -10. Then you grouped these together. X and 3x make 4x.
4.
-2 and -10 make
-12.
-12. Now, look at these two. Are they the same?
No.
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 That's the other way we can prove it, and that's the best way to prove it. Okay, if they don't simplify to the same thing, then they're not going to be equivalent. There may be one number that makes something equivalent, but all numbers won't make it equivalent. So your best bet is to simplify it and see if they are exactly the same. Okay? Questions you have for me on how to simplify expressions? Okay, your biggest thing you've got to remember is this subtraction sign belongs to the 3x. This subtraction sign belongs to the 10. That's why we make it a -3x and a -10. Okay? Otherwise, you'll drop negative signs. All right, who needs more time? All right, let's go to the practice problems then. Only if this cooperates. There we go. For each expression, write an equivalent expression that uses only addition. You are not simplifying this, you are simply changing it into an addition problem. Go. Keep all of the terms there, but I want them to all be added. No subtraction. Good. Looking good. Excellent. 20 plus -9 plus 8 plus -7. All right, do the next one. Kimberly, watch your signs in the B one. You dropped a sign on me. Either that or it's real small.
Yeah, I accidentally dropped a sign.
Okay,
I put it back in.
thank you.
Could we
Okay,
also just subtract 20 from 9?
I don't
and then
want,
take that answer and then add that to 8 minus
I
7?
don't want you to simplify it. All they're wanting you to do is turning it into an addition problem. Okay?
Okay.
You are right, we would simplify it if I asked you to. But the directions were simply to turn it into an addition problem. All right, good. So the second one, I'm seeing 4x plus -7y plus -5z plus 6. Well, let's look at this one and we'll talk about simplifying it. Can we simplify this one? We all know we can simplify the first one, right? Because they're all constants. Why can't I add 4, -7, -5, and 6?
Oh, because they have.
This is an x term. This is a y term. This is a z term. This is a constant. This is 4 apples, -7 oranges, -5 pineapples, and 6 yo-yos. Okay? We can't add them all together, can we?
That's random.
That's random, yeah.
My kid's party.
Okay? Notice, they are in order alphabetically. The proper form for writing expressions is alphabetical order by the variable, and then the constants at the end. Okay? All right, let's look at the next one. Good. -3x, nobody tried to change that one, good. Plus -8y, plus -4, plus -8/7z. And if I was to write it in proper form, I would switch these two right here. Okay? But I can't count it wrong because the commutative property says it's still going to be the same value. All right? Questions you have for me on that?
So you can't solve it. So the number B, you can't. Not number B.
And-
Letter B, you can't solve it until you have the values of
Right.
X, Y, and Z.
Right, I can't do anything with B and C. These are as simple as they get. I can simplify A because they're all constants. So that's where, who was saying that?
Me, Kimberly.
Yeah, somebody else was saying, can I add 20 and 8 and -9 and -7 and then combine those two? What property did I use? I used the commutative to move them around and the associative to put them together. Okay, that one you can simplify. B and C you cannot.
There's these on the track.
What?
There's these on the track.
Oh, okay. All right. Now we're going to do some simplifying. Use the distributive property to write an expression that is equivalent to each expression. If you get stuck, consider drawing boxes to help organize your work.
Can you go back real quickly?
Sure.
I just need to see it again.
Uh-huh. Are we good?
Yeah, thanks.
You're welcome. Not a problem. All right, so what I want you to draw for me is a box. Let me do it in black. I think black shows up better for you at home. Okay, draw me a nice long box. Split it into 3 sections. The reason I have 3 sections is there are 3 terms inside my parentheses. Okay, what does everything get multiplied by? 9.
9.
So the 9 is going to go right there. Then my first term inside is a 4x. Then I'm going to put a plus sign. Am I going to put 3y or negative 3y? Negative 3y because I'm changing subtraction to addition. I'm going to put a plus, and then it'll be negative 2/3. Questions on what I did right there? Now what you're going to think about is, how do I find the area of this box? I multiply this times this. So what is 9 times 4x? 36x. Okay. Now how am I going to find the area of this box? 9 times negative 3y, which is going to be negative 27y. How do I find the area of this box?
Multiply.
9 times negative 2/3, which is going to give me negative 6. So my answer, it's as simple as it can get, is 36x plus negative 27y plus negative 6. I cannot combine any of these terms. I have an x term, a y term, and a constant. They cannot be added together. Okay, questions you have?
I
Okay,
need a few seconds.
not a problem, Rachel. I've got other people still writing too. Now, if you're comfortable with the distributive property, you can just do that, and you'll come up with the same thing. Okay?
Thank you, I'm done.
Good. Just don't lose your negative signs. All right, do the next one by yourself.
Is that -1 or -1?
You tell me. I'm going to say yes. They both mean exactly the same thing. I just messed you up, didn't I? Get rid of subtraction and turn it into addition. What does it become? Plus a -1, right? So when you ask me, is it -1 or -1, I'm going to say yes, it's both. They are the same thing. All right, let's see what we got. 12x. Kimberly, you dropped a variable in the second box.
Oops.
Oops. And Nevaeh, are you stuck on what to do next? No. No? Okay. Jasmine, are you good? Chloe jumped straight to it. Good, she didn't lose any signs.
Oh, I did it on paper.
That's okay, good. All right, so what I'm seeing is, I'll do this for those that are struggling a little bit. I see -2 out here. I see -6 plus 3y plus -1. Whoops. That becomes 12x plus -6y plus 2. So that is my answer, as simple as it can be. I cannot combine anything because I have an x term, a y term, and a constant. Okay? Any questions for me? What you don't understand? What I can help you with?
So if it
I'm
was
still writing.
Okay?
like 12x and -6x, you could combine those and then add that to 2?
Can I? That's 12 apples and -6 yo-yos. Can I put them
No,
together?
if that was -6x, if they were both.
If they were both x's, yes, I could combine them.
Yeah, that's.
Yes. But since they're an x and a y, I can't. And you can't combine an x and an x squared term either. Okay? All right, Rachel, you good?
Yeah.
Okay. All right, let's try the next one. Go. Same process, it's just a fraction. Don't freak out. Yeah, Christina, it's not easy to write on that Chromebook, is it? Good. Looking good, DeMark. Shahan, what is 1/5 times 20? Good.
Wait, so you have to change it to addition, right?
Yes, ma'am.
Okay.
So this becomes 20y plus -4x plus -13.
Can you change the fraction to a sign?
No, just leave it a fraction. It's gonna take care of itself. It's fine. You can, but sometimes it's just easier to leave it as it is. Plus -13. Okay, so 1/5 times 20y is 4y.
4y.
And then we're just gonna leave this as -4/5 x. And then we're gonna leave this as -13/5. So our expression will be 4y plus -4/5 x plus -13/5. You can leave it just like that.
Could you actually say like the solution to 1/5 times -4x? Or do you have to put -4 over 5x?
Yeah, you have to, because you're gonna multiply 1/5 times -4, and that's gonna give you -4/5.
Okay.
Haley asked, can I change it into a decimal? Yes. You could make it -0.8x. And then you can change -13/5 into -0.26. No, 2.6.
Yeah, that's what I did. That's
That's
what I was
fine,
asking.
that's fine. Any other questions? I know y'all don't like fractions. All right, let's try the next one. Are we good?
Yes.
Okay. This one only has 2 terms inside the parentheses, so this time you only need 2 boxes. Go. Sam, sit up. Simone, is that positive 1/2 or negative 1/2? There you go, thank you. Good. Nevaeh, that looks good. Good, Jahan. All right, we look like we got that one. Negative 8x plus negative 4. Good. Questions you have on that one? That one seems so much easier, didn't it?
Yeah.
Okay, who needs more time?
Good Lord, there's always the one problem that has 5, 6, and 7 parts.
This is the last one of this problem. All right.
You sure?
Yep.
Yeah, that's a good question.
Are we liking the box to organize our work?
Yeah, I am.
Good.
Yeah. It's kind of easy, yeah.
Yeah, it makes it real easy. When I first saw this a couple years ago, I was like, man, I wish I had learned it this way.
You didn't?
No, I learned it just multiplying everything inside. I didn't even learn getting rid of subtraction. So I would always lose the negative sign in the middle of it. I'd always lose at least one of them inside.
I bet that was fun.
That was frustrating. After I did it about 100 times, I finally learned not to do it, but hey, I'm hard-headed. Looking good for the 1, 2, 3, 4, 8 of you that are doing it on here. Negative times a negative is a positive. So that becomes positive 8x
Yes.
plus positive 6y plus negative
Negative 20.
28. Nevaeh, not 20 down there at the end. Good. Questions you have that I might can help you with? I didn't draw that one out, but I will certainly do it if you need to see it.
Can you do it, please? For
Sure,
that check?
certainly. Okay, so I'm going to split it into 3 pieces. Negative 8 goes on the outside because everything's going to get multiplied by negative 8. Then I have negative x plus negative 3/4 y plus 7/2. So negative 8 times negative x gives me positive 8x. What's assumed to be in front of this x? What number is assumed to be right
A
here?
1.
A 1, okay? All right, then negative 8 times negative 3/4 is going to be negative times a negative is a positive, so that's going to be 6y. And then negative 8 times 7/2, that cancels to a negative 4, and negative 4 times 7 is negative 28. Okay?
The only thing I don't like about these tables that we're doing right now
Uh-huh.
is I lose the variable so easily.
Okay.
I forget to put the variable.
Okay. Maybe do the variable in a different color.
Yeah, I think that would help.
Maybe that would help. All right. Anybody need more time? Awesome. Okay, onward to problem number
I'm sure it's number 3.
2 or 3. 3, here we go. Kieran wrote the expression x minus 10 for this number puzzle. Pick a number, add -2, and multiply by 5. Lynn thinks Kieran made a mistake. How can she convince Kieran he made a mistake? He says they're equivalent. How do we prove if two expressions are not or are equivalent? I gave you 2 ways to do that. Do you remember?
To replace the variable with a number.
Okay, so let's replace the variable with a number. What do you want our number to be? Make it something small.
No.
What? 9?
Something small.
Yeah, something small.
3.
3, okay. What is 3 minus 10?
-7.
-7, okay. So over here we got -7. So now we're gonna pick that number. So we have 3, add -2 to it. What do we get? Do we get 1? Then we're gonna multiply it by 5 and we get, are they equivalent? No. Okay? Now, what would be the correct expression for the number puzzle? Well, we have a number, which we're going to call x. What do we do to it? What does it say? Pick a number, add -2, and then multiply by 5. So how am I going to show that I'm going to add 3 and -2 before I multiply by 5? Put it in parentheses and put a 5 on the outside. Can the 5 go in the back? Yes,
Yeah.
it doesn't matter. Commutative property of multiplication says it doesn't matter. It's just that's the normal way we write it. So does this expression right here, is this expression the same as that expression? No. That's the other way we can prove that they are not equivalent. And tell Karen he doesn't know what he's doing.
Go back to math class.
Go back to math class. Questions you have for me? All right. Can I move on?
Yep.
DeMarc, are you okay? I'll wait. I'll wait. Okay. The output from a coal power plant is shown in the table. Is the energy output in proportion to the number of days? If so, write an equation showing the relationship. So what are you going to use? What kind of strategy are you going to use?
Divide, right?
Divide what?
Y over x.
Y over x. Because what are we trying to find if there is what? What are we trying to find?
COP.
If there is a COP, so find the rates of each one of those and see what you get. Go. You may use a calculator.
That makes life easier.
Thank you.
Jahan, I think you went the wrong way. That's okay though. Your equation will just be different than our equation. You did x over y, didn't you?
Oh.
That's okay. You just get the other. Remember that there's 2 COPs and they are reciprocals of each other? Remember that?
I honestly don't remember that.
Oh, let's see. Where did we do that? There it is. The third anchor chart that we made at the beginning of the year. If we switch columns, the K is 1/3, the reciprocal of 3. See where it says proportional relationships and there's a table there?
Oh, no.
The third one, yeah. All right, so what do we get? Oh, a bunch of you divided that way. You wrote y over x and then you divided x divided by y.
Because it's natural to divide.
I forgot which
Okay.
column was X and which column was Y.
This is x, this is y, they're in alphabetical order. Okay, so you should get that. Now, if I go the other way, what do I get? 500,
500.
which is the reciprocal. Because this is 1 over 500 and this is 500. Now, if we were going to write the equation, we would write it in the form of y equals kx. So if we say D equals 0.002 E for energy, that's one of the equations. What's the other equation? E equals 500D. So what is that saying? How much energy do we get in one day?
500 megawatts.
500 megawatts.
That's a lot.
Well, I mean, either way, we're finding out. If we did it, I mean, it doesn't really matter what way we do it if we're just trying to find if it's proportional or not.
You are exactly right. Okay? And you can come up with either this equation or this equation because they're both right. All right, questions you have? Who needs more time? All righty, we are almost finished.
Yay, last problem.
Okay, in this table we have the output from a solar power plant.
Is this still number 4?
This is still number 4, this is part B. Is it proportional?
No, it's not.
No.
Should be pretty easy to see this one, right? Could we look at it this way? How do I get from 1 to 4? Times 4.
Times 4.
So what should that be?
400.
400. So this is no, it's not proportional. And
all of these, the first one has 1.
yep. Okay, now question. Why is it not proportional? Why would the solar power plant not be proportional?
Who knows? Because the sun is in different places.
The sun's in different places and for different amounts of time every day, right?
And different.
Okay.
Oh, my bad.
Questions?
And then if the sun doesn't come out at all, and
If it's like today, they wouldn't be making any
then
megahertz.
just nothing happens.
Yeah, nothing happens. All right. I noticed a lot of you have not taken the CPA 12. I know it was messed up last Wednesday, but you still need to go in and do that for me. This week, instead of having a turn-in of practice problems and independent practice, I put them all on one slide. So you have a Tuesday slide that on one side will have practice problems, on the other side will have the independent practice, which is Khan Academy, distributive property with variables. I would use the box to help you organize that. Then please do the lesson 19 slides before tomorrow. Take you about 10 minutes.
Or Thursday.
Thursday. And then work on Imagine Math and let's see if we can get past beat first core. We should, baby, because you've got more of the leaderboard than the other classes.
But we didn't know how to submit.
Okay, well now you know how to do it.
Okay, why is this not loading?
Bye, Miss Laird.
Bye.
Miss Laird.
Are you in the app?
Also,
No, I'm trying to get the,
Laird?
there
Yeah.
we go.
can you in the so
In the
on
period.
Thursday for last week, I never got the email of our
Okay, just tell me that. Just type it in the box.
Oh,
Okay.
that, okay.
then bye, Miss Laird.
Bye.
Thanks.
As
Bye.
soon as Haley gets back, okay? Can you wait?